research work. He is a PhD guide for MSc students and also PhD doers, and he is a life member of the National Science Society of the Material Science, American Nano Society, Indian Carbon Society, and Association of the Chemistry Teachers. He published more than 2 books, and also he delivered many seminars and arranged workshops. The total number of the seminars and workshops is more than 40, and he published 2 books. He is a syllabus former in a PG diploma course in biotechnology, University of Mumbai, SYBSc Organic Chemistry Paper 1, University of Mumbai, and his present position in university is Board of Studies member for Nanoscience and Nanotechnology, University of Mumbai, NSS area coordinator and of University of Mumbai. He awarded by many state level awards, national level awards, Young Scientist Award 2006, state level awards, Guru Brahma Awards in 2005, and state level awards, Vidya Bhushan Adarsh Shikshak Award in 2015. He does his research collaborate with different countries like University of Genoa, Italy, University of in South Africa, and also different states like Jaipur, Ahmedabad, Rajasthan, and he is a research paper reviewer. More than 4 international papers or journals he has reviewed, and I would like to Dr. Sandesh sir, please start your session.
Thank you, Rakim, for a very lengthy and wonderful about myself. So I'm a teacher, and then my hobby is research, and that's why I could collaborate with national, international, and everything. Am I audible?
Yes, sir.
Yeah. So, respected principal Rajkumar Kole sir, head of the Department of Chemistry, would be doctor, that because she has submitted her thesis, and that's why I can say is would be Dr. Amrita Singh, and all the teacher participant who has joined this webinar, and my dear student friends. Very good morning to you all. I think students are raising the hand. Why they are raising the hand? Aman Mishra, is there any issue? Please let me know. Aman Mishra, then Adarsh Pandey.
You can continue. They are just showing their presence.
Okay, the attendance remark. That's why.
Yes.
Good. So, but I confused why they are raising the hand, and that's why I asked. No issue. The topic from the Department of Chemistry and Vande Mataram College has given to me today. Okay, I will talk about the ultraviolet radiations. What is their use, their basic introduction, and then applications for chemical analysis. And if you want to analyze the chemical, then we are using the different spectroscopic technique for analysis. I will share my presentation from here. Where is option for share? Yeah, I got it. Okay, now I'm sharing the screen. Is it my slide is visible to you all? Yes, Amruta?
No, sir, it is not visible.
Wait, I will do it. Then I will share. Yeah. Now,
Yes, sir. Now it's visible.
okay, I will make now the full screen. Yeah,
Yes, sir, now it is visible.
slideshow and from beginning. Okay. See, this is the content of my talk, which I got that only now 45 to 50 minutes. I will interact with you, and I will talk about the spectroscopy, then electromagnetic radiation, then spectroscopy, its types, then UV visible spectroscopy, electronic transitions I will talk, and terms used in the UV visible spectroscopy and some applications of UV visible spectroscopy. I will cover this in this talk. It is very difficult to cover this in very limited time, but I would like to explain first what is the meaning of the electroscopy and electrometry. And these are the two words looking just like same, but one ending. Yes, please. Hey, make mute all participant. Hey, those who have the doubt, they can ask me, but mute all participants. I'm requesting all participants, please mute yourself. Otherwise, unmute करेंगे तो फिर आपकी आवाज मुझे सुनाई देगी. I know you are in different places, maybe at home and all, so it is very difficult. Then spectrometry is a word. It comes from एक minute. एक minute. Yeah, sorry, participant. So spectrometry is a word comes from materia. It's a Greek word, and its meaning is to measure. So spectrometry, it means we can measure the measurement of the electromagnetic radiation to obtain the information about system. Okay, in other words, we can say the spectrometry can be considered a method of studying the spectrum. If you are studying the spectra, that is spectrometry. And the another word which we are going to talk today is the spectroscopy. And that spectroscopy, I will split this word spectra and scopy. A Latin word specere means to look at, and scopia, that is we say scope, that is to see. Microscope, you can see in microscope. Okay, so that's means you are looking at the spectrum, what is its contents, what are its application, when it interact with matter, what happens. So spectroscopy is the study of interaction between the matter and electromagnetic radiation as a function of wavelength of the radiation or the frequency of radiation. Means how that electromagnetic radiation interact with the matter, and that study is called as spectroscopy. It is a usually non-destructive technique. So there are two types of techniques spectroscopics are available. One is called as destructive, means matter get destroyed during analysis, and non-destructive means your matter retain as it is. So this spectroscopic technique is a non-destructive technique, and the study of molecular or atomic structure, if you study the at atomic level, it is called as atomic spectroscopy, and if you are doing the study at molecular level, it is called as the molecular spectroscopy. From this spectroscopic analysis, we will obtain the information: quantity, matlab amount of matter present, and quality, what matter it is it. So that is the qualitative and quantitative analysis we can obtain. So what is this electromagnetic spectrum? So any beam of light having different frequency, different wavelength, when they interact with the sample, I say here sample. So what happens? May that light it transmit through it. This is called as transmission. Then there is a reflection. Then there is a refraction, and many things are happening because of when that a light or energy which is come in contact with the matter. Sometimes it is absorption and emission. These are the two major processes are takes place. Absorption spectroscopy. If that light is get emitted, emission spectroscopy. So spectroscopy are again classified into the absorption and emission. Our ultraviolet spectroscopy is a absorption spectroscopy. See, these are the matter. Matter means at the center here in this nucleus, and electrons all revolve around the nucleus. Now what we are doing, we are ejecting that radiation or the energy, and what happens, the electron which is present, suppose this is the first orbit, we provide some energy, and that we are ejecting the electron, means lower energy to higher energy. Once that electron absorb the energy, the electron get excited, means energy is absorbed, and that electron is captured and from the detector and will get the signal. Okay, so how is another animation? Can you see this animation, bachcho log? Is it visible? Amrita?
Yes, sir. It's visible.
Visible. Okay. That's why I confused. So I asked. Suppose, say this is the red part is your nucleus, and this is first orbit. This is second orbit. So initially, if the electron is present in first orbit, we apply some energy, electron get excited. And once the electron get excited, you see the speed of the electron. That speed is also increased. Okay, so that ejection means this is the matter. Any element you can take it, either hydrogen, carbon, whatever. That electrons are present outside the nucleus, and then we apply some energy on it. That electron get excited, and that how much energy required for the excitation, we can predict about its structure, and we can talk about its what material it is. See, so for generation of electromagnetic radiation, there are different techniques are used. How we can generate the electromagnetic radiation? One is the matter and antimatter. If you take one is positively charged and another is negatively charged, and you bring them together, and then spark takes place and it generates that electromagnetic radiation. This is the one way. This is the first. In the second step, particle-particle collision. And we can do the particle-particle collision, and what happens? They collide on very fast speed on each other, and again that electromagnetic radiations are generated. So different ways you can generate the electromagnetic radiations. I will come to what is meaning of this electromagnetic radiation. Now here just you understand it's a source of energy. हम लोग energy को create कर रहे हैं, है ना? कभी low energy है, कभी high energy है. So there are different techniques are used. When that electromagnetic radiations are generated, they travel in terms of wave. वो wave जैसा वो बाहर निकलते हैं. Okay, and if you apply the electric field, this blue line, blue wave is due to the, if you are applying the electric field. And if you apply the magnetic field, you see this red wave, it is the because of the magnetic field. So we can, their propagation of this light in terms of wave, we can change their propagation or their migration from one place to another place. Their energy get transferred in terms of wave. So you can apply the electric field or you can apply the magnetic field so as to that radiation you can allow to pass into the object or the material. So this is the source how we generate it, and here how we can apply the electric and magnetic field to change the line of propagation. Then the source, for UV visible spectroscopy, the source is used as a tungsten. Tungsten lamp, it is the ordinary lamp. It is there at our home also. And then tungsten lamp is a source of the visible light. वो visible light generate करता है. And hydrogen or deuterium lamp generate the UV region. So if you take this tungsten lamp and you pass the hydrogen gas as an inert atmosphere into it, you will get the UV visible double beam spectrophotometer. आजकल दोनों visible and UV ultraviolet light are together now. So just that inner gas that which is used here, the hydrogen gas is used and tungsten as a filament, and we'll get the UV visible source. With both light source we can get it here. You see that electric current is passed through it, and inside it that our hydrogen gas or deuterium lamp is there, and that light it generate, and that light you can pass through the different gratings and all, and to for the materials contact. Then what we understand from the previous 2-3 slide, we have this matter. Matter is unknown. Matter contains electrons are paired, or sometimes it is unpaired. That light means source of energy. We are generated artificially, and you can attack on this or target on this matter, and then what happens, the emission of electrons takes place. And that emission of electron, what energy it has, one we can say that is a UV visible spectroscopy. If it is again lower energy, it is IR, again lower energy NMR, again lower energy it is mass. So these are all the spectroscopic technique we will use for the different applications. Okay, so this is one slide. So what is electromagnetic spectrum? And at the most we are aware that different ways of transmitting the energy, and these phenomena come together in one physical entity is called as electromagnetic spectrum. The difference between the source of radiation is the amount of energy they radiate, and the radiation from these and other sources cover the range of the energies. See, this is the spectrum we plotted. Here is the frequency. You can see the frequency is very high. Wavelength, distance between the two crests and trough is called as the wavelength. EAR, difference between two successive trough, is also called as the wavelength. है ना, यहाँ से यहाँ तक का distance आप लोग ले लेंगे. Okay, from here to here. This is we call as lambda. Here the lambda, if you measure in the centimeter, almost it is 20 centimeter. Suppose if I take the lambda of here, the lambda is just like 1 centimeter. It means lower the lambda, higher the energy. Okay, and gamma ray, they are having highest energy radiation, gamma ray. Then X-ray, then ultraviolet light, then visible light, then infrared, microwave, radio waves. All these are the different types of energies. And if you plot all the different energy radiation in a one graph, and that spectrum is obtained, and that is called as electromagnetic spectrum. Okay, so what is the difference? It is the energy, but their wavelength is different. Gamma ray, their wavelength is very low, but for visible light, their wavelength is high. Because one Einstein's equation, E equals to h nu, and h nu means nu is the frequency, that is c by lambda. If the wavelength is high, energy is low. If your wavelength is very low, energy is very high, and that is we say energy is inversely proportional to wavelength. Okay, and we can get some idea that gamma ray is highest energy radiations, रेडियो वेव्स मोबाइल में यूज कर रहे हैं हम लोग, आज इंटरनेट में यूज कर रहे हो रेडियो वेव्स, दे आर लो एनर्जी रेडिएशंस and we'll use it for different applications. Previous slide, here again we can talk about the how these radiations, see the gamma radiations having the different very high frequency, x-ray thoda sa wavelength बढ़ गया, फिर ultraviolet wavelength बढ़ गया, visible light you look at this wavelength, infrared wavelength, again this microwave wavelength, and radio waves is a very longer wavelength, and so lower energy, and energy is very low. And you can see these are the nomenclature used to understand about how these radiations are different from each other, and we can generate them individually by using the different techniques. हम लोग अलग-अलग techniques से उसको use कर सकते हैं. Then what is the use when these radiation come in contact with matter? अगर कोई भी matter के साथ ये radiation का contact होता है तो होता क्या है? Just you can look at here. Gamma radiations अगर molecule के साथ आ गए, interact किया, तो क्या करेंगे? They directly enter into the nucleus because they are very high energy radiation. They burst the nucleus. वो nucleus को burst करते हैं. जैसे nucleus burst किया तो nuclear fission, nuclear fusion, जो भाभा एटॉमिक रिसर्च सेंटर में होता है, वो न्यूक्लियर रिएक्शंस करते हैं. सो गामा रे इज अ वेरी पावरफुल रेडिएशन, दे बर्स्ट द न्यूक्लियाई. उसके बाद आता है एक्सरे. एक्सरे क्या करता है? यू नो देयर आर द इनर इलेक्ट्रॉनिक ट्रांजिशन बोलते हैं. आपने बोन का भी एक्सरे करते हैं. एक्सरे रेडिएशन नेवर एंटर्स इनटू द बोन, वो बोन तक जाता है, वहां से फिर रिफ्लेक्ट होते आते हैं, एक इमेज क्रिएट होता है. एंड दैट्स व्हाई मींस इनर इलेक्ट्रॉनिक ट्रांजिशन. इनर इलेक्ट्रॉन का मतलब क्या? न्यूक्लियस है हमारे पास, 1s इलेक्ट्रॉन है, 2s इलेक्ट्रॉन है, 2p है, एंड 3s एंड ऑल. सो 1s इलेक्ट्रॉन को इजेक्ट करने का, रिमूव करने का काम एक्सरे करता है. सो दैट इज कॉल्ड एज इनर इलेक्ट्रॉनिक ट्रांजिशन. एक्सरे इनर इलेक्ट्रॉनिक ट्रांजिशन. अगर हम लोग यूज करते हैं यूवी विजिबल लाइट, है ना, हमारा जो सनलाइट आ रही है हमारे पास, दैट इज अल्ट्रावायलेट लाइट and visible light, there is an electronic excitation, that outermost electron get excited from lower energy to higher energy because of absorption of light, and higher energy to lower energy because of emission of light. दोनों काम करता है. इलेक्ट्रॉन जंप करते हैं, अपन बोलते हैं इलेक्ट्रॉन जंप करता है. जंप कब करता है? अगर एनर्जी एब्सॉर्ब किया तो लोअर टू हायर ऑर्बिट में जाएगा. अगर एनर्जी रेडिएट किया तो हायर एनर्जी टू लोअर एनर्जी आएगा. दैट इज द मैकेनिज्म वी वर गोइंग टू डिस्कस हियर. IR क्या होता है? इंफ्रारेड में द मॉलिक्यूल विल नॉट नेवर एक्साइट द इलेक्ट्रॉन, दैट एनर्जी इज नॉट सफिशिएंट, बट वो मॉलिक्यूल को क्या कर सकता है? आइदर वाइब्रेट इट जस्ट लाइक अ स्प्रिंग, बॉन्ड बिहेव्स लाइक अ स्प्रिंग, इलेक्ट्रॉन बिहेव्स लाइक अ स्प्रिंग. सो आइदर वाइब्रेशंस आर पॉसिबल. And microwave, there is a rotations, molecule is getting rotate in microwave, okay, and other nuclear magnetic resonance is a different concept is there. So whenever that different energy radiation come in contact with the molecule, either nuclear fission, nuclear fusion, electron inner electron transition, then electronic transitions also takes place, outer electronic transition because of UV. So that is our main focus today. When ultraviolet light come in contact with any molecule, there is a outer electronic transition, and electron get excited, and that is we can say that is electronic excitation in simple word. Then you can see that there are different I am again with the electromagnetic radiation, you know, gamma ray, x-ray, वैक्यूम यूवी, दे आयोनाइज द मॉलिक्यूल. वो मॉलिक्यूल को आयोनाइज कर लेते हैं. ओके, देन अगर यूवी एंड विजिबल लाइट को अगर हम लोग लेते हैं, देयर इज एन इलेक्ट्रॉनिक ट्रांजिशन. यू नो, आयोनाइजेशन मतलब क्या करना? इलेक्ट्रॉन को कंप्लीट रिमूव ही कर देने का. So sodium है, so sodium we can convert into sodium ion because one of the electron from the sodium we have removed it. That is ionization. But in electronic transition हम लोग क्या करते हैं? We are not forming any cations and anions. हम cations and anions generate नहीं कर रहे, but we are exciting the outermost electron from lower energy to higher energy, and that is we say electronic transition is takes place. Different spectroscopy, there are different molecular changes are occurs. I am not going in detail of other. Then again here Again, this radiations and what kind of the source are used, and then what happens, what kind of in the spectra details in front of you. If you use mass spectroscopy, देखो आपको ऐसे line spectrum मिलेगा in mass. Chromatography, paper thin column. NMR, again, it is there, nuclear magnetic resonance one. IR, you will find here the inverse peaks are there in IR. Then atomic absorption spectroscopy, again line spectrum, and UV spectroscopy, you can see it, you will get a broad hills like structure है ना, ये ऐसे hills मिल जाते हैं. This is lower hills, this is another hill, it is there, and we will get the different of the hills, that is peaks are obtained. Then another point is the same, again we are continuing those who are not understanding the previous slide. So X-ray, gamma ray, they are nothing but they break the bond, ionization takes place. And UV visible spectroscopy, they excite the electrons. And again, if there is a lower energy, that is infrared radiation, they vibrate the molecule को just वो vibrate कर सकते हैं. एंड अगर वेरी लो आ गया एनर्जी उससे भी तो मॉलिक्यूल को रोटेट कर सकते हैं, उसको हम लोग माइक्रोवेव बोलते हैं. माइक्रोवेव में मॉलिक्यूल को रोटेट करके मॉलिक्यूल को एक्साइट किया जाता है. सो एनर्जी डिफरेंस हो गया, मॉलिक्यूल का डांस हम बोलेंगे, ये इलेक्ट्रॉनिक डांस बोलेंगे, ये अलग अलग टाइप्स का करेंगे, डिपेंड्स अपॉन दैट एनर्जी. So again here it's a comparison. I'm just saying here these are ionization, जैसे gamma ray, X-ray, ये bond को break कर लेते हैं and ionization बोलते हैं अपन. Ultraviolet light को excite करते हैं, electronic excitation, and infrared molecule को vibrate करता है and microwave molecule को rotate करता है. So these are all radiation. What is the difference in these radiation? Only their wavelength, their energy is the difference. Then these are the slide. I don't want to say why we appears as a color क्यों हम लोग देखते हैं, because this is a very basic thing. Otherwise I will not get time to cover my portion. You see a white light, if it pass through a prism के through अगर हम लोग pass करते हैं, तो that single white light, it gets splitted into this number of lines. And you can see that the ray get bent in a different angle. So is a red light, the red light appears here. VIBGYOR, we can say VIBGYOR. VIBGYOR, these different colors are appear like rainbow. Rainbow also it has seen in our sky. That is the white light. It composed of the different lights. What is the difference in there? Because they are different in their wavelength. उनका wavelength जो है वो अलग है. Okay, so if the material, अब अगर अपना material ने completely reflect किया light को, है ना, पूरा total light को reflect किया, तो it appears as white. मतलब absorption किया ही नहीं material ने, reflect किया light को, it appears as white. If the material absorb a constant fraction of light across the spectrum, constant उसने absorption किया, it appears as gray. And if the material completely absorb the light, पूरा light को उसने अगर absorb किया, all light, it appears as a black. So either whether it's reflect, absorb, or how the material, so on that basis the color will reflect it. You see the wavelength, the color absorb and color we see with our eyes. If the color absorbed light is violet, its wavelength is 380 to 430 nanometer. Okay, this is the wavelength of light, and then it appears as yellow. If the color absorbed by the material is blue, means 430 to 480 wavelength light it is absorbed, it appears to us it's yellow, and so on. Okay, अगर red light को absorb किया, तो it appears as blue. So this is the red means is having the very low wavelength, and blue is the high wavelength. I can show this one is a triangle, you already learn it, which light absorb and which light will get it. Suppose if that yellow light is absorbed, it appears as violet. If the blue light is absorbed, it appears as orange. If the red light is absorbed, it reflects the green. So these are the triangle. This is we call as the complementary colors. We learn it, which light absorb the material and how they appears to us, which color. So these are the complementary colors we can visualize with our eyes. And then another animation example, I have just put it just to understand. See, this is the visible light, 7 colors. This is ultraviolet light, and this is the IR light. So which light which falls on this object, it appears as a different color, you see. So these are the complementary colors we can see which wavelength of light is absorbed. Okay, this red light, and here is the thermometer is shown. It means the red light is having the intensity is different and the temperature is also different. So this is just to understand how we see the color from the which light wavelength color is absorbed and which color is appears. So this is the just animated video I have brought it here to understand about the how the objects becomes color. Then how this electronic excitation is observed here. You see, this is ground state, means that the molecule, it is at normal conditions. And if you put the light or bombard the light of UV visible light, okay, what happens? That electron get excited. है ना, electron excite हो गया. S0, that is S मतलब state, ground state to singlet excited state. पहला excited state में electron energy लिया, फिर यहाँ तक jump किया. That is called as, this is ground state and this is excited state. Okay, so if we use the energy radiation of IR, so IR में again you see the energy required, IR is very less, but for UV energy is very high. And about this microwave, so effect of the energy level depending upon the nature of energy received. है ना, हमको कौन सा एनर्जी रिसीव कर रहा है उसके ऊपर इलेक्ट्रॉनिक एक्साइटेशन और वाइब्रेशन. सो दिस इज वी कॉल्ड एज वाइब्रेशन लेवल एंड दिस इज वी कॉल्ड एज द रोटेशन लेवल एनर्जी, vibration energy, and this is the electronic excitation energy. So again here we clear about the how that electron get their change is takes place when they interact with the different energy. What is the UV technique? If you see the color, red color, it appears at a lower wavelength. Color, red color is red graph. UV में आपको यहाँ मिलेगा red. If you are having this blue color, you can see this blue color. Then it is green. And if you slightly change the color intensity, the absorption wavelength is changes. Okay, these are the different chemicals. They have shown here the structure, not name, but it's okay. We are not worried about this. हम लोग इतना ही ध्यान रखेंगे कि हम लोग का जो लाइट हमको अपीयर करना है. So in UV visible spectrophotometer आपको ऐसे पीक आएंगे. अगर रेड है, it appears only up to 500 to 600 nanometer wavelength, you will get this peak. आपको ये peak मिलेगा. If it is blue, then again there is an higher wavelength. And you see for this greenish, it is again 750 to 850. So these are the molecules, but the structures are different. Their absorption of UV light is also different. So we will use the UV light for detection of the structure or detection of the unsaturation present in the compound, double bonds present in the compound, because the absorption is due to the double bond. I will talk about how the electronic excitation and everything takes place in another slide. So we understand about the frequency, we understand about the wavelength. Frequency is nothing but the number of wave passed through in 1 second. That is frequency. Gamma radiation is very high frequency. Okay, wavelength is the distance between two successive crest and trough is called as the wavelength. Wavelength is lambda, it is in centimeter. Longer the wavelength, lower is the energy. Okay, so this is all about. So this is amplitude is nothing but the height of wave. ये wave का जो height है, it is called as amplitude, and distance between this two successive crest or two successive trough is called, this is crest, they say trough, है ना. लाइट प्रोपोगेट इन टर्म्स ऑफ वेव. लाइट अगर यहां से यहां जा रही है वो कैसे जाएगी? इन द फॉर्म ऑफ वेव. ओके, ये लाइफ ऐसी वेव के रूप में जाएगी. एंड विद द हेल्प ऑफ दिस वी कैन कैलकुलेट एनर्जी, है ना. फ्रीक्वेंसी इज डायरेक्टली प्रोपोर्शनल टू एनर्जी. फ्रीक्वेंसी बढ़ गया, एनर्जी बढ़ गई. Then another is energy is inversely proportional to wavelength. देखो hc by lambda, lambda is lower, denominator में आ गया, तो wavelength अगर बढ़ गया, energy कम हो गई. So that we understand from this spectrum. So this is the visible light, that is we called as visible light is 7 colors, and then ultraviolet light is quite higher energy compared to the visible light. You know, ultraviolet light 190 to 400 nanometer, इसको बोलते हैं ultraviolet light. Okay, ultraviolet light is 190 to 400, 400 to 800. Okay, that is we called as the visible light. है ना, 4 से 800 nanometer wavelength. This is I am talking about the in terms of wavelength only. वेवलेंथ हम लोग मेजर कर सकते हैं इन सेंटीमीटर्स में. अगर वो वेवलेंथ 400 टू 800 है, उसको हम लोग विजिबल लाइट बोलेंगे. अगर लाइट का वेवलेंथ 190 टू 400 है, उसको हम लोग अल्ट्रावायलेट लाइट. एंड अगेन लाइट इज कंपोज्ड ऑफ डिफरेंट कलर्स, उसका भी उन्होंने अलग अलग दिया है. वायलेट कलर है तो 400 टू 420, इंडिगो है तो 420 टू 440, है ना. रेड है तो 620 टू 780. रेड का कलर देखो, रेड हम लोग को जल्दी दिखता है कलर, मतलब हाई एनर्जी कलर है वो. और उसका वेवलेंथ देखो, है ना, इसका वेवलेंथ 620 टू 780, वेवलेंथ ज्यादा. ओके, and that color is color intensity is high. So the again it's a comparison to understand. Then how this origin of UV visible spectra takes place? Origin takes place only due to the ultraviolet light. Plant synthesize their food. Plant अपना खाना बनाता है, कैसे? Because of sunlight. So that energy from the light, it is absorbed, and then electronic excitation takes place and molecular reactions, that is we call as photochemical reactions, are takes place. So that energy we have to measure it. So types of spectroscopy: atomic spectroscopy, molecular spectroscopy, that already we understand. Then see in this is the schematic representation of UV visible spectrophotometer. वो कैसे दिखता है? हम लोग पहले क्या करते हैं कि एक मिरर होता है एंड उसके पहले लैंप है. हम लोग दोनों लैंप यूज कर रहे हैं, डिटेरियम लैंप आल्सो एंड टंगस्टन लैंप. दे रेडिएट द एनर्जी, वो एनर्जी जनरेट करते हैं, मिरर के ऊपर फॉल होती है, एंड देन इट गोज टू द फिल्टर. ये फिल्टर होता है, एंड वन टाइप ऑफ एनर्जी इट पास थ्रू दिस मोनोक्रोमेटर, and then it goes to the beam splitter. Beam splitter में एक radiation goes to the reference में, जहां हम लोग हमारा solvent रखा रहता है, and another इसमें हम लोग हमारा sample. And then again ये light and ये light data processing में आके you will get a here signal. Here is the I0, that is transmitted light. So that is called as incident light, and this is IT is a transmitted light. दोनों का ratio लेते हैं I0 by IT, and we will get the पिक here. ये हमको ऐसा पिक में, that is we call as absorbance. और ये किस वेवलेंथ पे एब्जॉर्ब किया, that is the characteristics of that material. So this is the simple double beam UV visible spectrophotometer. अगर ओनली आप टंगस्टन लैंप करते हो, उसको अपन कैलोरीमीटर बोलते हैं. एंड ड्यूटेरियम लैंप एंड टंगस्टन लैंप यूज कर रहे हैं, तो इसको बोलते हैं हम लोग डबल बीम यूवी विजिबल स्पेक्ट्रोफोटोमीटर. See, prism के through जाने के बाद how this light gets splitted into the different wavelength, and this is red, yellow, and these are the different violet colors. Means when a beam of light radiation passes through the prism, they form. They may absorb, they may reflect, they may refract it, and many more. Absorb radiation affect the electronic and chemical bonds in the sample. Light अगर absorb किया तो वो किसको affect करता है? Electronic transition के लिए absorb करता है, and the absorbed radiation leads to the emission of lower energy proton. है ना, lower energy protons वो emit करते हैं. Here there is one same experiment animated. It is shown here just to understand. I will just show you. You can see this is our source of light. ये हमारा source of light है. When हम लोग ये automatically instrument के अंदर on कर देते तो the light can generate. These are the slit through which the light can pass. Prism is there and one more slit is there, and then it goes to the beam splitter. Beam splitter मतलब एक light इधर आ जाएगा, same light goes here. This is your reference, means solvent रखते हैं, and यहाँ पे हम लोग sample रखते हैं. And then here there are the detectors are present, and these detectors they receive that light. This is we called as 100% transmitted I0, and this is IT, and then it goes to the plotter के लिए चला जाता है. Then I can just see when light glows, ये bulb glow हो गया. अब ये glow होने के बाद light through slit हम लोगों ने पास किया on prism. जैसे prism को किया तो then there is a different color of light, because this is the tungsten and deuterium lamp is used to generate the visible ultraviolet and visible light, and it goes to the again slit, and then it goes to the beam splitter. Okay, from the beam splitter it passed from the reference and the sample cell. The sample cell response के through pass हो गई light, and then it goes to the detector. Detector के through ये जाएगी, and then what happens? This plotter is there, and that this is I0, this is IT, and then when we take the ratio of this I upon I0, we will get the point here. Then if you add the molecules, sample में हम लोग क्या करते थे, अभी molecules को add करते हैं. I have added one molecule here. Again we pass this light and we'll get I0 and IT ratio, and we'll get one more reading. आपको reading यहाँ पे मिल गई. Okay, हम लोग ने और एक molecule add कर दिया, और एक molecule add कर दिया. Again number of molecule in concentration increases. That here you see we will get another point, and in this way we can generate the graph from this reaction. This kind of plot is obtained here. This is percentage transmittance. If it is absorption, inverse दिखता हो. Here is the concentration, and this is percentage transmittance. Either you can take the transmittance or you can take this. So this is the sample which contains this molecule. As the molecule increases, transmittance decreases, and this kind of graph will get it. And these are the equation, mathematical expression and all. We can take it, and we can finally calculate the concentration of unknown substance and everything. So this is the all about the video about the how that ultraviolet spectroscopy is takes place. So UV radiation, मैंने already आपको बोला, and visible radiation is nothing but this. Under point, when incident light goes through the sample, either is transmitted, that is we call as IT, and these are the formulas are used to measure the transmittance, and then we can have the percentage transmittance, and then we can plot this. But generally we are not using the transmittance light, but we are using the absorb light. If it is suppose this unsaturated compound is benzene, it appears absorption is here, red color. If it is anthracene, number of double bonds are increased, its wavelength also increase. And if again here 1, 2, 3, 4 and 4 rings are there, again its lambda mass increase. Means the number of double bond increases, that lambda shifts to the higher wavelength. Okay, this is benzene देखो, it is near about 217 something. Okay, 217 तक. फिर anthracene आ गया, it is 314, sorry, it is 284 something आ गया. And अगर ये आ गया तो again it goes to the 300. It means these are the absorptions, है ना? This 1, 2, 3. As the double bond increases, absorbance increases. So I'm skipping this part. हम लोग absorbance में बोले ना, we are not taking the transmittance, we are taking the absorbance. So log of transmittance, you take it, you will get the absorbance, and your peak is looks like this. This is B sample, its peak, and this is A sample, this peak. So in UV, the broad peak are appear. UV में broad peak मिलते हैं. So Beer and Lambert law, that I don't want to explain the basic thing. Okay, then because all these laws are based upon the Beers and Lambert. And UV visible technique is UV. So because of this UV spectroscopy, there is a transition takes place, electronic transition. There are 3 different types of electrons are present in a different molecule. Agar saturated compound hai, only sigma electrons are present. Unsaturated compound hai, uske andar double bond hai, pi electrons are present, sigma electrons are also present. And if there is an ketone carbonyl compound, that is pi electron is also there, double bond, and then non-bond electron is also there. Okay, and that's why there are different types of electronic transitions are takes place. Sigma electrons in saturated compound, pi electrons in unsaturated compound, and non-bond electrons in the heteroatom like oxygen, sulfur, nitrogen, halogen. They contain the non-bond electron. So what happens? These are the different types of electron present in one molecule. The electron get excited. If there is a sigma electron, sigma star, sigma to sigma star transition. You see, I'm writing here, the sigma electron is having very low energy. They are stable. Pi electron is having the more energy, then non-bond electron, then pi star, and then sigma star. These are the anti-bonding. This is we can called as bonding, and this is we called as the anti-bonding. So bonding electrons and anti-bonding. When the electron goes to anti-bonding, when they absorb the energy. वो अगर वो energy absorb करते हैं, तो they goes to the anti-bonding. So this is 1 minute. Then see, these are the transitions are explained. This is very important for organic chemists to understand. If the sigma electron, you see the energy sigma star, very high energy is required, and that transition is called as sigma to sigma star transition. मतलब sigma electron goes to the sigma star transition. मतलब ground state, excited state. Then if there is a pi electron, so pi में क्या क्या possible है? One pi to pi star is also possible. Pi to sigma star is also possible. So there are 2 transitions are possible. See, the energy required for pi to pi star, ये energy है, is low compared to pi to sigma star. Then if there is a non-bond electrons are present here, so n to pi star and n to sigma star. So these are the possible transition. मतलब n electron may jump here to pi star, or may it jumps to the sigma star. So depending upon the structure, the electronic excitations are present. And this is the massive. हम लोग कुछ नहीं कर रहे. We are just bombarding that UV radiation on it. And because of the type of electron, the excitations are takes place. And मैंने ये बोला कि sigma to sigma star requires very high energy. UV the not possible to get sigma to sigma star. है ना, UV से हमको sigma to sigma star होगा नहीं. तो UV is only used to detect the double bonds or the heteroatom. मतलब UV में pi to pi star हो सकता है, n to pi star हो सकता है, n to sigma star हो सकता है, but sigma to sigma star transition, this energy is not sufficient for the UV. So saturated compound you cannot detect with the help of UV light. UV light से हम लोग saturated like methane you cannot detect, ethane you cannot detect, ethene you can detect because ethene is a double bond. So possible electronic transitions यहाँ पे sigma to sigma star, pi to pi star, n to sigma star, n to pi star, sigma to pi star, and pi to sigma star. There are 6 different types of transitions are possible. Okay, depends upon which electrons are present. अगर मुझे बोलते हो कि सबसे लोवेस्ट एनर्जी किसको लगेगी, मैं बोलूंगा n to pi star transition required very lower energy. वो एनर्जी हमको कहां से पता चली? You can see this transition here. मैं बोला ना n to pi star, सीधे एनर्जी, इतना ही एनर्जी लगा उसको जंप करने. Then उसके बाद pi to pi star, then n to this, and then another is this, and सबसे ज्यादा एनर्जी sigma to sigma star. So these are the possible transitions. Sigma to sigma star transitions are takes place is excited from sigma to sigma star. Saturated, the energy required is very large. The organic compound in which the valence electrons are involved in the formation of sigma bond do not show absorption in normal UV. Normal 200 to 400 में sigma to sigma star transition is not possible. And this transition is observed with a saturated cup. फिर हम लोग बोल सकते हैं कि the given compound is saturated because there is no absorption of light is takes place here. Then example methane, ethane, मैंने ऐसा अभी बोला ना कि these cannot be used this UV spectrum, but we can use vacuum region to detect this one. Okay, vacuum UV visible spectroscopy is also there for saturated compounds. Then under is a pi to pi star transition. So pi electrons in bonding orbital is excited to the corresponding anti-orbital pi star. The energy required is very less compared to N2 sigma star. उससे भी ये energy कम है. So compound containing multiple bonds like alkene, alkyne, carbonyl compound, nitrile, aromatic, etc. undergoes pi to pi star transitions, and we can detect them. So what is that 170 to 205? This is the absorb. If there is a peak appear, we can say the given compound is unsaturated. इस region में अगर ये peak आपको मिला UV का, compound is unsaturated. Absorption is usually occurs at ordinary UV. Absorption bands in conjugated alkene. अगर एक double bond है और एक double bond आ गया, दो हो गए, lambda max increases. तीन double bond trine हो गया, again lambda max increases. So absorption is directly proportional to the double bonds. So absorption band in carbonyl compound is 180. Alkene में 170 होता है और carbonyl compound अगर है तो 180 है. Then N to sigma star transition. अब ये किस में आएंगे? जैसे alcohol, because in alcohol there is a heteroatom present O and H. So oxygen contain the non-bond electron, and because of this single bond here, that there is a N to sigma star transition. I mean alcohol, ether, amines, है ना? Though they are the saturated compound, but there is a non-bond electrons are present. N electrons are there. That N electron is excited to sigma star. And that transition is possible, and this transition requires lower energy than the sigma to sigma star transition. In saturated alkyl halide अगर है तो halide is present, the lone pair is there, that is non-bond electron is there, so N to sigma star transition is possible. So we can detect the heteroatom containing compound with the help of UV visible spectroscopy. Methyl chloride lambda max is 173, methyl iodide lambda max is 258, है ना? तो हम लोग कंफर्म कर सकते हैं just by using pick. कोई chemical reaction करने का जरूरी नहीं है. You take methyl chloride or maybe some solvent, you can use it. You will get an absorption peak at 173 nanometer. And if it is methyl iodide, 258 nanometer. मतलब the electronegativity plays an important role for the lambda max. And this is very sensitive to the hydrogen bonding. Alcohol agar hai hydrogen bonding broad peak, amines hai hydrogen bonding broad peak, wavelengths get shorter, है ना? उनका shorter wavelength में आ जाते हो. N to pi star, yes, again C double bond O, heteroatom भी है, non-bond electron is there, pi electron is there. So this non-bond electron goes to the pi star. So carbonyl compound, nitro, है ना? Many aldehydes, ketones, everything, they are N to pi star transition is there, and they can also detect in this spectroscopy. That is N to pi star and pi to pi star. दोनों transition हो सकता है यहाँ पे. So these electronic transitions are, some electronic transitions are called as forbidden, and some electronic transitions are called as allowed. Allowed transitions are nothing but N to pi star and pi to pi star. These are the allowed transition, and sigma to sigma star, N to sigma star, they are the forbidden transition because they are theoretically possible. Practically, the electron excitation with UV is not there, and that's why it is called as the forbidden. मतलब theoretically है, practically नहीं है. So terms used in spectroscopy is called as chromophore. Chromophore एक term use करते हैं. Chromophore मतलब containing the color consisting group. All double bonds, they are color consisting. Unsaturated groups, they are color consisting. Okay, and that's why they are called as the chromophore. Chromophore means color consisting. So double bond O, double bond, they are chromophores. See, double bond अगर 18 है, which transition is possible? अगर pi electron है तो pi to pi star, ये pi to pi star. Wavelength किस में absorb होगा वो 171 पे हो गया. If there is a carbon-carbon triple bond है, तो again here pi to pi star transition is possible. Now here C double bond O है, so दो transition possible है, एक तो pi electron है pi to pi star, and non-bond electron है तो N to pi star. So two transitions are possible. Their wavelength. Okay. इधर भी डबल बॉन्ड O है, लोन पेयर भी है, pi electron is also there. So pi to pi star transition, N to pi star transition. Yes, there are two transitions are possible here. Okay. Then you can see CX halogen here. N to pi star transition is also there, and N to sigma star transition is also there. Depends upon. So N to sigma star, because all they are saturated. N to sigma star transition. N to pi star is not there. Sorry. N to sigma star transition is there. And generally we can use, these are the solvent. हम लोग solvent system use करते हैं to dissolve. So in UV visible spectroscopy, we need to dissolve the compound in a respective solvent. हम अलग अलग solvent में उसको dissolve कर सकते हैं. Nowadays the solid UV is also available. अभी पहले dissolve करने का जरूरी नहीं है. You can take the solid UV visible spectroscopy, and as for solid compound also, no need to use the solvent. So that is advancement is takes place in UV spectroscopy. Exochrome, and this is एक हमने देखा chromophore. Unsaturated groups are called as chromophore. Saturated groups are called as exochrome. मतलब color intensity is also changed because of the exochrome. So these are the coordinated saturated compounds or unsaturated groups themselves do not absorb the radiation, but when they present, they enhances the absorption property of chromophore. And वो help करते हैं absorption, and also known as the color enhancing group. The intensity of the color is increases. It is only due to the exochrome, presence of the saturated group. All exochromes, one or more non-bonding pair electrons are present, like amine, nitrogen के पास दोनों pair है, oxygen and nitrogen. All they are saturated. Okay. But they act as an exochrome, NH2, OH, SH, all alkyl group, that is one. So the effect of exochrome on this benzene in UV, it absorbs at 255 nanometer. है ना, benzene अगर हम लोग उसका UV लेते हैं, तो you will find a peak at 255 nanometer. वही हम लोगों ने क्या किया कि एक हाइड्रोजन को रिप्लेस किया by OH, and this OH is an exochrome. ये OH exochrome है. तो अब देखो इसका एब्सॉर्प्शन 255 था तो बढ़ गया 270. So because of this presence of OH group, that shift in wavelength shift हो गया for higher, okay, that is 270. हम लोग ने ऐड किया NH2 group, again NH2 is an exochrome, again you see the wavelength is 280. So exochrome, there is a bathochromic shift बोलते हैं हम लोग उसको, मैं आगे बताऊंगा what is, there are different types of shifts are takes place. Shift of wavelength from lower to higher is always the bathochromic shift. मतलब higher wavelength पे चला गया. So exochrome increase the absorption wavelength, वो बढ़ाता है. So हम लोग structure determination में हम लोग इसको use कर सकते हैं. अगर only benzene है 255, अगर there is OH group 270, if there is NH2 group on benzene 280. So these are the value fixed. Theoretically also we can calculate these value. The Woodward and Fisher rules are used. I don't know I will get today time or not to explain that, but maybe in the next lecture I can explain. Theoretically also we can calculate these number. ये wavelength number हम लोग theoretically भी calculate कर सकते हैं. Yes, I'm just talking about the different type of shift. That is bathochromic shift is called as red shift, hypsochromic shift, blue, hyperchromic, and hypsochromic. You just see with the help of this one, इससे हमको पूरा total clear हो जाएगा. If this is your absorption wavelength, and if this absorption wavelength due to presence of chromophore or exochrome वो इधर चली जाती है ना, higher wavelength पे जाती है, red shift बोलो, इसको बोलते हैं bathochromic. दूसरा है कि it goes to the lower wavelength because of chromophore and exochrome, it is called as hypsochrome. इसका मतलब absorption shifts toward the lower wavelength, hypsochromic, and shifts towards the higher wavelength, bathochromic. If sometimes absorption intensity is increases, है ना, ये ग्राफ इतना है but ये increase किया, that is called as hyperchromic shift, and absorption intensity may get decreased, it is called as hypochromic shift. Hypo lower, hyper higher, batho longer wavelength, and hypso shorter wavelength. So these are the 4 different types of terms used in the UV visible spectroscopy, and there is a shift in wavelength, or there is an increase in intensity of the color. It is due to the chromophores and exochromes, or sometimes solvent also plays an important role. So already I talk about the bathochromic shift because of the OH group, that all exochromes, there is a bathochromic shift. Like see, this is the paranitrophenol. It absorbs at 255 nanometer, but if you put the NaOH solution into it, it forms sodium phenoxide ion, and this is increase in 265 nanometer. Well, sometimes we can say that whether the reaction is takes place or not. So this OH is having ONA, here is ONA, and then we can say the absorption you will take before UV and after adding NaOH UV. So there are different, there is a bathochromic shift. Then hypsochromic shift is again due to the effect of presence of the group, which causes the removal of conjugation. है ना, कभी-कभी आपने पास conjugation है, like this is aniline, and you add HCl to it. What happens here? Non-bond electron and pi electrons are there. But now these non-bond electrons are not available because it forms a salt with aniline. Aniline के साथ salt form किया, तो हमारा जो conjugation था वो कम हो गया, तो there is a hypsochromic shift. So aniline 280 nanometer, but anilinium ion, that is 203. This value is 280 to 203 हो गया because reduction in conjugation. Conjugation कम किया, there is a hypsochromic shift. Okay, hypsochromic shift. Then hyperchromic intensity कब बढ़ती है? Generally the pyridine, it absorbs at 257 nanometer, but in case of methyl pyridine, you can see that intensity, that epsilon, that is 3560 is increased here. Wavelength में कोई ज़्यादा change नहीं आया, but the intensity, epsilon, height of the wave height of the peak, we can say, not wave, height of the peak is increased because of this methyl. So exochrome generally increase the absorption intensity. Then hypochrome means intensity kam ho gayi. This is naphthalene. Its intensity is 19,000, and then if you put one methyl naphthalene, and its intensity get decreased, and because of this methyl group is an exochrome, decrease the height of the peak, and therefore it is called as the hypsochromic. So these are the ideas we learned from the UV spectroscopy. Here the pi electron is there, so pi to pi star transition is also possible if there is a pi electron, and then alpha beta unsaturated ketone, again here pi to pi star transition, and then N to pi star transition is also possible. You can see it here for carbonyl group, N to pi star transition, energy देखो कितना कम लगता है, and this is pi to pi star transition. And these transitions are, we can see with the help of this graph, number of double bonds. Suppose this is R, CH2 double bond CH, taken N times. N means number of double bond increase. If you increase the number of electron, N equals to 5, pass double bond कर दिया मैंने, तो you see the absorption wavelength. If N is equal to 4, lower wavelength. N is equal to 3, again lower wavelength. इसका मतलब number of double bond increases, bathochromic shift. There is an increase in wavelength. आपका जो पीक है वो अलग अलग जगह पे अपीयर हो जाएगा. इधर 3 डबल बॉन्ड है तो इधर आ गया, 4 है तो 300 से आगे गया, 5 है तो it goes again 350 to above. So what we learn from this, if the double bond get increased, the wavelength is also increases. So we can calculate the number of double bond present in the organic compounds. Yes, we can. So here is again effect of theirs, that is substituted compound, the wavelength. If this is cis-stilbene and this is cis-stilbene, this is trans-stilbene, trans-stilbene 295, cis-stilbene 280, and because of steric hindrance, there is a change in the UV light. And a pi to pi star transition. Okay, this is solvent, effect of solvent. Solvent also plays a very important. No solvent अगर है, pi to pi star transition very high energy. अगर polar solvent डाला तो pi to pi star transition आ जाएगा lower energy. Okay, here again pi to pi star and n to pi star transition. No solvent, very high energy. Solvent है lower energy. Effect of pH. pH also plays very important role. Sometimes pH means reduce the conjugation. There is a hypsochromic shift. And a conjugation reduce karta pH means either you can add acid or alkali to decrease the pH, and the chemical reaction takes place with lone pair, and then conjugation is reduced. Conjugation reduce ho gaya, there is a hypsochromic shift, lower wavelength. Effect of temperature, yes. If you perform that UV visible spectroscopy analysis at 20 degrees at room temperature, you can say you get a very good peak. And if you again cool it under minus 195 degrees centigrade in suppose in liquid nitrogen or all, so you can see the number of peaks scattering. And this is the fine structure, but different absorption is takes place. But this is the normal room temperature we are using. So effect of temperature is also effect of concentration. As we know, concentration increases, wavelength increases, and that is the effect of the Beer and Lambert law. Okay, so expected that sample concentration is directly proportional to the intensity of absorption. मतलब ये दोनों proportional है. Color dark है. In summary, so chromophore is a functional group which is responsible for the absorption of UV. Chromophore चाहिए हमको, otherwise UV visible absorption नहीं होगा. Exochrome do not absorb but increase the absorption maxima. Shifting of absorption maxima towards longer wavelength is called as red shift, and towards shorter wavelength is called as the blue shift. Red and blue, that is batho and hypso. Hypochromic shift decrease the absorption intensity because of that exochrome present, and extending conjugation wavelength absorption shifted to the higher value. एक double bond है, दूसरा double bond आ गया, तीसरा आ गया, तो higher wavelength पे चले जाएंगे. Temperature, concentration and pH of the sample affect the position and the shape of the UV absorption band. And recording the spectra at low temperature gives a sharp absorption band, whereas at the high temperature causes the broadening. अगर temperature बढ़ गया तो broadening हो सकती है. And changes in the pH sample solution changes the absorption maximum. So this is all about बच्चे लोग. I have covered this part. I could not take some other applications and example to see how that UV visible spectroscopy used to detect the unsaturation of the compound. Is there any question? I'm ready to answer your questions. But the presentation, the time which is allotted to me, I have completed here. Yes, anybody would like to ask any question, please ask. Yes, Amruta. Hello. Hello.
Yes, sir.
Yes, yes. Now, is there any questions from your side where you can ask? Because I have completed the 1 hour. So
Yes, sir. Yes, student, if anyone having any doubts, you can ask.
I think there is something written in chat. I don't know who is. Okay, is the feedback form list. Okay.
There is
sir,
no
already sent.
There is no question means if they understand fully and they are there is a one possibility
Yes,
they
sir.
didn't understand anything.
Yes, sir. They understand 100%.
Maybe I was too fast. No, na.
No, sir. It is okay.
It is okay. Okay.
Thank you, sir. Kanaya, sir.
Thank you, Rajkumar sir. Rajkumar sir has given the opportunity to me to interact with the student. So convey my regards to our Vande Mataram College principal and management chairman.
Yes, sir. Sir
Thanks
is
to
there.
all the faculty members and the participant who listen very silently my talk. So thank you very much, Amrita. Thank you to you also because of
Sir, I have
you.
asked Kanaya, sir, to please vote of
Yes.
thanks.
Yes, ma'am. Yes, ma'am. Good morning to all. It is an immense pleasure for me to deliver a vote of thanks for the today's webinar. I would like to thank today's guest, chief guest, Dr. Sandesh Javame sir, for delivering a wonderful speech and sharing his knowledge with us. So thank you very much, sir. Now I would like to extend my thank to our president and principal, Dr. Rajkumar Kolle sir, vice principal, Ms. Vanita Lokhande ma'am, head of department, Dr. Amrita Singh, and all the organizing committee and the technical support staff. So thank you all of again. Last but not the least, I thank all the participants. Thank you.
Yes. Thank you, Rajkumar sir. Thank you very much. Can I leave Amrita now? Amrita madam, photo हो रहा लिया?
Hello, sir.
Yes, sir. Sir, namaste, sir. Namaste. I was looking at you only, but maybe you are busy. Thank you, sir. Today I have delivered a talk on UV, but it's a virtual talk. So maybe student, I cannot see what they learn from this talk.
Hello.
Hello, sir.
Hello, sir. Yeah, sir. Yeah. Sir, good morning. Good morning.
Good morning, sir, and thank you. I say thank you to you.
Sir, most welcome.
Yes.
I could not attend, sir. I was busy, quite busy. Some for other interview work is going on in the college.
Yes, sir. Yes, sir.
Means 50% I was available in the.
Okay, okay, sir. Thank you. I was looking. You are there as a in the list of participants.
Yeah, yeah. Yes.
Yeah.
Thanks a lot, sir, for your valuable time.
Thank you, sir. Thank
Please
you.
come. You please, whenever the school college will start, you please visit to our college also.
Definitely, sir. Definitely. It's my pleasure, and I'm very happy to see you also
Yeah,
in
yeah.
campus. Yeah. Thank you.
Thank you, sir. Thanks a lot.
Thank you, sir.
Participants and special thanks to Amrita, yeah, Kanaya, and all the entire chemistry department. Thanks a lot.
Thank you, sir.
Okay, sir. Thank you.
Can I leave, sir, now?
Yes, sir. Yeah, yeah. Thank you.
Thank you. Thank you, sir. Bye. Have a nice time.
Good evening, sir.